Let's talk about cosets. We're going to look through a lot of examples of cosets. So I have a group G, I have the order. What can we say about the subgroups? Well, we're going to work on this quite a lot. And we can define cosets. This is called a right coset. It's just you take every element, H and H, and you multiply on the right by some particular G. So for each G, each little g, you're going to get a right coset of H. And then you can also have left cosets. So wherever the non-H element is, although it could be an H, this is a right coset and that's a left coset. And they're just defined similarly. You're just going to take every element and multiply by something a second. G is called a coset representative. A coset representative is just any element in the coset. G is one of them. So, right cosets. And here's some examples. Cyclic group over 6, and H is going to be 0, 2, 4. Well, following right cosets. And that, I just take every element of H and multiply on the right by 0. So here is the 0. These zeros are all the same. This 0 corresponds to that 0. So you get the same thing back. Well, we can look at H plus 1, plus 1, plus 1, plus 1. And that, these two are equal, so that's actually equal to H. Okay, H plus 1 appears being low point. There, 3, 5, 1. That's 4. There we go. My computer's being slow. I apologize for that. You end up with, you get that. So these are all the right cosets. I added every element of G to the right there, and I got a bunch of things. But notice we only actually got two different things. We got those three, and then we got these three. But notice that we have three different names for each. So if you look at the set 1, 3, 5, we have three good names, coset names. It's equal to H plus 1, it's equal to H plus 3, and it's equal to H plus 5. This is a lot like fractions. Fractions, if I want to write down the fraction 2/3, I can do that, but there are other ways of doing it. You could write it as 6/9. You could write it as 10 15ths. You could write it as 20 30ths, or 2,000 3,000ths. So just like fractions, there are a bunch of names for the same thing. You also have different sorts of names, but we'll ignore those for now. Cosets, you have a bunch of different names for the same coset. So that causes some issues later on, but we won't. So, oh, it is blue. I picked the colors right. That was luck. Oh, yep. Like I said, they're just two different names for the same thing. Or you have many different names for the same thing here. Here's another example. Let H be from the symmetric to the right cosets. I can multiply on the right by the, and I'm going to get EE and 1, 2. So I just you almost think about this as just stripping it through, and you just get, this is the identity. 1, 2. This E. Now look at 1, 3, 1, 2 by 1, 3. And then 2, 3. H2. There. In this case, we get three different cosets. Look, those two are the same. They're both in red. And they're both in kind of like a nice mauve color. So, again, we have different names for the same cosets. This is one name for the coset. That's another name for the coset. Which coset? Coset's just a subset of the group. It's formed in a particular way, so we just don't want to call it plain old subset. But it's formed in a particular way that's just you multiply every element of a subgroup on the right, because it's a right. Okay, now although the cosets, we saw that there are actually only three cosets. Once again, the three cosets are here. There are different names that you could have had. Right, there are multiple names for all of them. If you want to write H, you could write it as H times 1, 2. That would work as well. So each coset has two names. and 3 if you're the identity, because you can just do H. That's it. Thank you.